particle of mass 0.2 kilograms is moving in a smooth horizontal surface at speed 3 meters per second. Looks like so. 3 meters per second. Struck by an impulse of I perpendicular to the original, so I will come in there. And it deflects it through an angle of alpha, so that's what I go off. That's an angle of alpha to its original direction. And it says that tan alpha is 5/12. As soon as I see 5/12, I'm thinking 5/12/13, opposite over adjacent. So I'm going to get, if that's my angle alpha there, the opposite will be 5, adjacent will be 12, and the hypotenuse will be 13. Now I'm going to use an impulse momentum triangle. So I've got impulse, which we know, equals gain in momentum, which is the final momentum, take away the original momentum. When I'm doing triangles, I like to have two arrows adding together to get the final one. So I normally like to have the impulse plus mu equals mv. And now I can do it. The impulse, I've got to show what it is. That's going straight up. Notice that this is not a triangle because this is just a velocity and this is an impulse, and ours is an impulse momentum triangle. And so this bit here would be the mass, which is 0.2, times by the initial velocity, which is 3. And that bit equals the final momentum. So from the beginning of the first arrow to the end of the second arrow, that's the red bit, and that's mv. And now I can work out what I've got a right angle triangle, so therefore I can use SOHCAHTOA. And if I dot this, it's quite the hardest bit sometimes is working out where angles go. But if I put this through here, then you can see that this is my alpha from my original diagram here, and therefore this bit here is also alpha because it's vertically opposite. Now I can do it. SOHCAHTOA, I want the opposite. I've got the adjacent, so I'm going to have tan TOA. So I've got the opposite, which is what I want, equals tan alpha times by the adjacent, which is 0.6. And so the opposite equals tan alpha, which is 5/12 times by 0.6, and that does equal 0.25 as it wanted up here, and that's impulse, that'll be Newton seconds. And I've got to find the speed of p after the impulse acts. Well, that's pretty much just given here, because if I work out the length here, then that will be mv, and all I have to do is divide by 0.2 to get the velocity. So part 2, I've got, I must use the adjacent and the hypotenuse. So SOHCAHTOA against right angle triangle, and the hypotenuse equals the adjacent over cos of alpha, and the adjacent is 0.6, and cos of alpha is, well, we know that cos is adjacent over hypotenuse, that's 12/13, and that equals 0.65, but that's not what the velocity is, that's mv. So that's mv, and therefore v equals 0.65 divided by the mass, which is 0.2, and that equals 3.25 meters per second. And that's question 1 done.